And a happy day to you. Let me do a video of something that came up in class yesterday, and I have a longer video on exponents, roots, and logarithms that's got a lot more computation in it, but let me just run the basic idea in this video. So let me share my screen with you. Oh, we gotta get the iPad pulled over. All right, there we go. So, if you remember from, I don't know, 6th grade, 7th grade, an exponent means repeated multiplication. So if I said something like 2 to the 5th, what that means is I've got 5 2s. 1, 2, 3, 4, 5. And so this answer then is going to be 32. So 2 to the 5th is equal then to 32. But when we do exponents and roots and logarithms, we kind of rearrange all of these things. And you have to know what the names of these things are. I've never seen this in a textbook. Haven't seen it presented this way. It took me some time to maybe kind of sort this all out. Maybe I still don't even have it all sorted out. But this is the best I got at this moment in time. So let's just do a real basic one. If I said 3 squared, what's that equal to? You're going to say 9. And now let me talk about the names of these things. Each one of these little number elements has a name. 3 is called the base, so I'll write the word base right there. The 2 is the exponent. Most everybody knows that. And it has to be written as a superscript. So I'm writing on the screen the words in the same physical spatial arrangement that you would write the numbers. And then the 9 then is the answer to an exponent. What do you call that? Do you know? The answer to an addition question is a sum. The answer to a multiplication question is a product. The answer to an exponent has got a different name. And I've got a very entertaining story about that. Maybe I'll make a second video after this one and share the story with you. But 9 is actually called a power. And the reason most people don't pull that out right away is because there's sloppy vocabulary use. We call 2 the power. No, 2 is the exponent. 9 is the second power of 3. If you map that out with grammar, you'll realize that the term power applies to the number 9. 9 is the power. But in any case, there you go. That's probably familiar to most of you. Now, if we were to kind of reverse the process and start with 9 and go backwards, it would look something like this. You would say, well, how do you then take 9 and reverse the exponent? You would say 9, the square root of 9, that's equal to 3. Now, in looking at this here, I had 3 numerical elements to begin with, a 3 and a 2 and a 9. But when I do the square root, where did the 2 go? Well, technically you don't write it, but the 2 would go right there in the little V crook of the square root symbol. And if it's not written, if there's no number written there, then it's understood that it's 2. If it's a cube root, then you have to put that in there and so forth. But anyway, here's what this looks like. If we just rearrange the pieces, what's the 2? The 2 would be the exponent. And all of you math people are losing your minds now at this moment. Play along. Okay, what is the 9? The 9 is the power. And what's the answer? The answer is the base. See, the answer to an exponent is the power. The answer to a root or a radical is the base. It's asking me here, it's saying, what's the base? When I square that base, that gives me 9. And the answer is 3. Now, maybe you might say, well, plus or minus 3. I'm not going to get into the sign issue on that. But just let's talk about the terms. Now, mathematicians don't call it these things. They've actually got separate names for these. They would call the thing that's inside the square root symbol or the root symbol, they would call that the radicand, because the square root symbol itself is the radical. And whatever the number is up there, the thing that's the exponent, they call that now the index. But isn't that the same thing as the power and the exponent from the previous exponential situation? Yeah, it is. It's just you're rearranging the pieces. And they don't even bother to tell you that it's the base. They just say it's the answer or something like that. Or at least as far as I know, there's not a separate thing that tells you that the answer to a root is the base. Isn't that interesting that roots and bases kind of have the same meaning even in just language? If I build a building, I have to put it on a base. If I took it a tree, what does the tree sit on? Well, the root. I just found that interesting. So anyway, there's three elements. There should be a third arrangement. What's the third arrangement? The first one here I have, well, the answer to an exponent is the power. The answer to a root is the base. Shouldn't there be a situation where the answer to the question is the exponent? Yeah. What's that? It's logarithm. Okay? Logarithm. If I rearrange all these pieces now, it would look like this. Let me scroll up a little bit, see if I can get it all in the field of view. It would be log base 3 of 9 is equal to 2. Logarithm is asking what's the exponent, and I'll spell it out here. What's the exponent on the base of 3 that gives me 9? That exponent is 2. So if I'm going to write it out now spatially with words, it would be log, and then the base has to be written down below the line. It's a subscript, just like the exponent was raised. You have to raise the exponent. It's a superscript up above. The base has to be dropped. And any good DJ would tell you that. Log of the base, no, log base such and such, of the power. The power is what goes inside there. And sometimes that's called the argument, but argument just means whatever you're doing something on. Like you could have an argument of a trigonometric function. It doesn't necessarily mean a power. But in this case, it would be the log base something of the power is equal to, let me squeeze it in here. Oh, come on, I can get it all in view. Here we go. Here we go. Love my iPad. Exponent. So that's how you rearrange all of those different pieces. All three of these things are related, just in a different form. So for logarithms, log base 5 of 125 would be equal to what? Can you think about that? What exponent do you raise the base of 5 to get 125? That would be 3. Oh, let's do another one. Let's do a fun one. How about log base 7 of 1/7? You're like, what in the world? Isn't that negative 1? You know about negative exponents? 7 to the negative 1 is 1/7. Yeah, so anyway, I hope that that's a little bit helpful. Those three things go together. In my opinion, logarithms should be taught using just regular numbers at the same time or in the same sequence as exponents and then roots and then logarithms. So maybe like 6th or 7th grade. The problem is that the way we teach it nowadays, the way some people teach it, I don't. The way some people teach it is they wait until Algebra 2 to introduce the idea of logarithms, and then it's immediately done with algebra, and it just confuses people. Like it's a sharp on-ramp to get up to the algebra level of logarithms, and kids are like, what's this strange log stuff? It's just the answer when you want to know the exponent. Logarithm asks, what's the exponent? But in any case, maybe I'll just hit stop and then record the video of me and Professor Berger talking about the thing. Anyway, hope you have good... I'm not going to reshoot the video over that edit. Hope you have a great day. Bye-bye.